Our video today is about solving exponential equations. Uh, right here on number one, we have an exponential equation because it's an equation involving x as an exponent. And so what we want to do is we want to figure out what value of x would take place to make both sides of this equation equal. Well, we have 5 to the power of x equals 125, and you could basically use logic to figure out what that would be, or you can go ahead and adjust this all to have the same base. So 5 to the x, 125 is 5 to the third. Well, that makes x 3. So the only way to make this true is if x is 3. Now, if you had a situation with an exponential function, but there's more to it, you want to try to get the exponential portion to be isolated. You want to get it by itself. So we treat it as an algebraic situation with that getting alone first. So we can subtract the 4 on both sides. We can divide by 5 on both sides. So now we get 3 to the power of x minus 7 equals 9. Well, we know what 9 is. 9 is the same thing as 3 squared. We can get this common base. And when these two expressions are equal, it's not like 3 to the 14th equals 3 squared. No, this number right here needs to be 2. So we can go x minus 7 equals 2, and so our x value is 9. For the third problem, I have a mistake here. This should be -3. Otherwise, the problem does not work. So we're going to solve this exponential equation with the right-hand side equals to -3. Well, the first thing we would have to do here is try to get the exponential portion by itself. So we have this 2 we can subtract away. So we have -80 times 4 to the power of 2x minus 1 equals -5. We're going to divide by -80 on both sides. And here, since these are multiplied, we can go ahead and reduce them. So we have 4 to the power of 2x minus 1 equals 1/16. Now, 1/16 is a power of 4, and because it's possible to get bases here the same, we can get 4 to the 2x minus 1 equals 4. Well, 1/16 is 4 to the -2nd, because 4 squared is 4 squared is 16. We do a negative power, puts it into the denominator. And here then we'd have that 2x minus 1 equals -2. And we're in a position that we can go ahead and solve. So we had 2x equals -1, x equals -1/2. We could check this one and we could check all of them. If you go ahead and input -1/2 here, you would get 4. 2 times -1/2 is -1. This here is 4 to the -2nd, or 1/16. So 2 minus 80 times 1/16 will equal -3, because this is 2 minus 5 does equal -3. It's true. Now, in number 4, I look at it and I'm seeing that we have these bases of 81 and 27. And 27 squared is a number way bigger than 81, a number that I don't know off the top of my head. But we notice there's some similarities between 27 and 81. Both of them are powers of 3. So what we're going to do is we're going to get the bases of these to be the same. So 81 is the same thing as 3 to the 4th. This here is our 81, and that's being taken to the 3x minus 2 power. And then 27 is 3 to the 3rd. That's being taken to 5x plus 7 power. Well, now we have a power to a power. And what we've been doing here is if we have power to power, you can multiply these exponents. So it's 4 times the 3x minus 2, or 12x minus 8. And over here, we have an exponent of 3 times the 5x plus 7, or 15x plus 21. Well, since the bases are exactly the same, we know that these values would be the same if their exponents were the same. So you had 12x minus 8 equals 15x plus 21, and you get, uh, if I subtract the 12x over to this side, I get 3x. If I subtract 21 on both sides, I get negative 29. So x equals negative 29 thirds. It feels weird, so I'm just going to double check it really quickly. So negative 29 thirds would mean that we have 81 to the negative 31st power equals 27 to the, let's see here, 29 times 5 is 150 minus 5. So that's 145 thirds. Negative 145 thirds plus 21 thirds. So let's see here. I'm keep double checking this in the purple. So I have 81 to the negative 31 equals 27 to the negative 124 thirds. Well, 81 is the same thing as 3 to the fourth to the negative 31, which is, but it's not 27, it's 21. Sorry, not 21, it's 27. So we have 3 cubed to the negative 124 thirds. This power to a power right over here is going to be negative 124. This power to a power here is going to be negative 124. It is true. Then in number 5, we're going to do the same thing. Here, this 4 is the same as 2 squared. And here, this 1/8 is the same thing as 2 to the negative third power. So power to a power, we multiply the exponents, 2 to the 10 minus 2x, and this is 2 to the negative 9x minus 12. So we know that then these exponents are both equal. 10 minus 2x equals negative 9x minus 12. So we'd get 22 equals negative 7x, or x equals negative 22 sevenths. Then in the sixth one, there looks like there's just a lot more going on. So, but still, I noticed something about each of these bases. Each of these, this is 9, 1/3, and 27. They're all powers of 3. So when we go look at those bases, we can change them to be all the same base. 3 squared is 9 to the 3x plus 1, times 3 to the negative first, which is 1/3, to the negative 2/3 x, equals 3 to the third, or 27, to the negative 2x plus 4. Power to a power, we can multiply the exponents. We have 3 to the 6x plus 2 times 3 to the 2/3 x equals 3 to the negative 6x plus 12. Well, when you have power times a power, we add the exponents. So we have 3 to the 6x plus 2 plus 2/3 x equals 3 to the negative 6x plus 12. So we can go ahead and set these exponents equal to each other. 6x plus 2 plus 2/3 x equals negative 6x plus 12. So we have 12x plus 2/3 x equals 10. This is 36 thirds, so we have 38 thirds x equals 10. So x equals 30 38ths.